Hi, Algebra 2. In lesson 4 here, you're going to be working on finding the inverse of trig functions. Here we go. When we talk about the inverse of trig functions, it essentially means if we know what the sine, cosine, or tangent of something equals, we're going to look and find that angle that gives us that ratio. You're going to see it written like this, where you have that little -1 up there. That is read as the inverse sine, and that's what this down here is telling us. It's not the reciprocal, but it's the inverse. The inverses of the trig functions are not functions themselves because, remember, a function can only have one output for every input. But with the inverses of the trig functions, there can be multiple outputs. For example, if you want to find the cosine, the inverse cosine of 1/2 right here, well, that's basically telling you what is the angle that is going to give you a cosine value of 1/2. Now, if you think about your unit circle, there's going to be multiple values that have a cosine or an x value of that coordinate of 1/2. So they give you an example here. 5 pi over 3 is going to have a cosine value of 1/2, but so does just pi over 3. And then we could keep going all the way around and add on another 2 pi to this and have another value that's going to have a cosine value of 1/2. So the inverses of trig functions are not functions because there are multiple possible answers. So in this first example, we're going to find all possible values of the inverse cosine of square root of 3 over 2. And so I'm drawing it on my unit circle right here. I'm using my unit circle. I'm going to find these values that have a cosine value positive square root 3 over 2. Cosine is the x value, so cosine is going to be positive in this region in quadrants 1 and 4. So from our unit circle, we can see that pi over 6 has a cosine value of square root 3 over 2, and so does 11 pi over 6. So those are two possibilities. But we also need to remember, what if we add on 2 pi? We're going to be right back, in this case, at pi over 6. So what we're going to say here is that every time we add on 2 pi, we're going to be right back at that pi over 6 value that has a cosine of square root 3 over 2. So we're going to say plus 2 pi, and then we'll put on a variable there, n, meaning we could go around 2 pi, a full circle, as many times as we want, and as long as we add that pi over 6, we're going to be right here with that cosine value. Same thing down here, we'll add on 2 pi, and we can do that n times, as many times as we want, and we'll still end up at this value with the cosine of square root 3 over 2. In this one, we're finding all the possible values where the inverse tangent is 1. And so what are the angles that give us a tangent of positive 1? So remember that tangent of theta is going to equal our y value divided by the x value. So we need our x and y values to be the same in order for the tangent to be 1. And so we notice that this angle, pi over 4, if I divide those x and y values, I'll get positive 1. And then over here in quadrant 3, negative divided by negative, same value there would give us a tangent of 1. So this angle right here, pi over 4, and then the other angle that matches it is 5 pi over 4. Now, same thing, we have to add on 2 pi as many times as we want to both of these, because as we go around that circle, every time we land there, we're going to have a tangent of 1. This table from your book is giving us all kinds of notation about the inverse functions. When we talk about the inverse functions, if you see them with a capital letter, that means that they are restricting the domain and range of those functions so that we don't have to worry about going around the circle as many times as we want. We don't have to worry about adding on the 2 pi as many times as we need. So for sine and cosine, we're going to have a domain, or we're restricting the inputs to from -1 to 1. For tangent, we're still going to have any input available. For the ranges, we're restricting the possible answers. In sine, we're restricting it to just this part of our circle, going from negative pi over 2 to positive pi over 2, or negative 90 degrees to positive 90 degrees. For cosine, we're going to restrict our answers to go from 0 to pi, or from 0 to 180 degrees. And for the inverse tangent, we're going to do the same as sine, going from negative 90 to 90 degrees. When evaluating these inverse trig functions, your unit circle is going to be very, very helpful. So in this one, the inverse cosine of negative square root 3 over 2. So this means you're looking at your unit circle and you're finding a value where your x value is the negative square root 3 over 2. Now remember, cosine, we just saw earlier, is only going to be, or it was only going to have a range in quadrants 1 and 2. And so on your unit circle, you are going to be looking at this point right here. And I'm just going to draw a line going through that, because that's where our cosine, or our x value, is negative square root 3 over 2. And when you look on your unit circle, you will see that this goes along with the point 5 pi over 6, or in other words, 150 degrees. Now this problem wants your answer in both radians and degrees. In this problem, we are finding the inverse sine of 3/2. Now remember back to that previous table, we are restricting the domain of this inverse function so that the inputs have to be between -1 and 1. 3/2 is the same as 1.5. And so this is out of the domain. And in this case, that means that it is undefined. Here we're going to find the inverse sine of negative square root 2 over 2. Now I'm just reminding us that the range, which means our possible answers here, have to be between negative pi over 2 and pi over 2, or in other words, negative 90 to 90. So this part of our unit circle is what we're looking at. So to solve this, I'm going to use my unit circle, and I'm looking for a point where the y value is negative square root 2 over 2. And it has to be within our range. And so I see this point right here, which has the cosine and sine values. And this is the one I'm worried about, is the sine value. I want it to match up. And I notice that this point is at negative pi over 4, or in degrees, negative 45 degrees. On your unit circle, you'll see that point listed as 7 pi over 4, or 315 degrees. But remember that those are not within the ranges of answers that we need for the inverse sine. And so instead I have to think of it as the negative angle instead. Now we're going to solve this using a calculator, and we're going to solve sine theta equals 0.4. So what angle measurement has a sine ratio of 0.4? Now we want our answer to be between negative 90 degrees and 90 degrees, because that's what they're telling us in our problem here. So the first thing on your calculator, make sure you're in degrees. You can see that with using the little wrench there, or if you're using a scientific calculator, it's kind of right at the top of where your numbers are. And then we'll do the inverse sine function and just type in 0.4. And so we get our answer in this case of 23.58. And that's going to be our answer for theta, 23.58 degrees. So that's the sine angle, or that's the angle that's going to have the sine ratio of 0.4. Now our answer is within the range that we're asking in this question, and so we're good to go. Here we have the same problem, but we want our answer in a different range. We want our answer now to be between 90 and 270, so somewhere over in that area, quadrants 2 and 3. So I've drawn out what we know so far. We know that the angle here that gives us this sine ratio is 23.58 degrees. So I've drawn that here, and then I've labeled, and I know that sine is my y value. I don't know cosine right now, but it doesn't matter. I know that sine is my y value, and I need to find another angle that has that same sine value. So I'm going to look over in this direction, because over here, again, we don't know cosine, but that doesn't matter. But our y value, that sine, is still going to be positive because we're above the x-axis. And so I need to know this angle right here. Well, I know that the distance from my x-axis up is going to be 23.58, but I need the measurement going from 0 to here. So that's going to be 180 minus 23.58. And I get 156.42. So that answer is now in the range that I want, and I know that it has the same sine value as my original angle.